Welcome to The Explainer. Today, we're tackling a seriously fascinating frontier in the tech world, modern AI connectivity. Look, we've all seen how insanely capable individual AI models have become over the last couple of years, right? But we are absolutely sitting on the edge of a major paradigm shift. It's no longer just about a single, isolated AI sitting in a chat window answering a prompt. It's about creating these dynamic ecosystems where completely different AI systems actually talk to one another. So how do we build that? Well, that is the exact architectural puzzle we're exploring today.
Okay, let's dive into this. The fundamental question driving today's explainer is beautifully simple. How do modern AI agents connect and work together? But make no mistake, this is a massive engineering hurdle. We're talking about getting autonomous AI agents, systems built by entirely different developers, running on completely different underlying logic, to actually collaborate seamlessly. I mean, if we want AI to handle multi-step workflows, imagine an AI researching a topic, handing it off to another AI to draft a report, and then a third one autonomously publishing it. These agents absolutely must be able to communicate. Without that connection, we just have very smart silos.
To navigate all of this, we're looking at a recent breakdown by Anasup Consulting, which captures a massive debate happening among developers right now. Grounding our discussion in their work gives us a really direct lens into these specific integration architectures. You see, the conversation isn't just abstract theory anymore. It's a highly relevant, real-world engineering challenge. They establish exactly why understanding the connection between modern AI agents is the critical next step. The true power of modern AI is going to be unlocked not just by making isolated brains smarter, but by building the nervous system that connects them all together. So before we look at the specific frameworks, we really have to define the ultimate goal here. The fundamental requirement is for modern AI agents to bridge their isolated environments to function as a unified system. Think of it like having a bunch of brilliant human experts, right? But they're locked in separate rooms and they're all speaking completely different languages. That is the state of a lot of AI today. And bridging those environments is incredibly difficult because you're dealing with disparate coding languages, mismatched context windows, and super strict security barriers. The whole goal of an integration architecture is basically to provide a universal translator to solve those massive technical problems. And that brings us to the main event, the ultimate showdown between MCP and ADK. The developer community is actively wrestling with how exactly to build these bridges, and our source material explicitly frames this as a clash of frameworks. It's this super energetic debate between two distinct philosophies vying to become the gold standard for wiring the future of artificial intelligence. Actually, instead of just being a theoretical preference, this is a choice between a standardized approach to context sharing on one hand versus a highly specialized toolkit approach for agent development on the other. It's literally a structural decision that dictates how autonomous agents are built and deployed from day one. So let's look at the competitors in this arena. As our source outlines, there are two primary competing architectures. First up, we have MCP, which stands for Model Context Protocol. MCP is essentially an open standard designed to help AI models securely connect to local and remote data sources, giving them uniform access to the context they need. Second, we have ADK, or Agent Development Kit. An ADK functions as a robust suite of specialized tools and libraries specifically built to help developers construct the internal logic, behaviors, and actions of an autonomous agent right from the ground up. These are the two leading paths developers are testing out to get highly intelligent agents interacting without the whole system breaking down. And this brilliantly illustrates the dynamic at play. When placing MCPs side by side against ADK, we see competing pathways to the exact same goal of a unified AI ecosystem. In real-world application, MCP excels at standardizing data ingestion. It acts kind of like a universal plug, so an agent can effortlessly read files, pull from databases, or browse the web using a common language. ADK, conversely, focuses on execution and agent-to-agent logic. It provides the exact frameworks needed to script how an agent routes tasks, makes decisions, and triggers external tools. So developers have to weigh the distinct advantages of standardizing context with MCP versus standardizing agent behavior with an ADK. So the crucial point is this. No matter who ultimately wins this architectural showdown, the underlying mission involves two sequential steps, derived straight from our source. Step 1, connect. Step 2, work together. It sounds so simple, yet it's absolutely monumental in practice. Whether you're implementing MCP or routing a project through an ADK, the architecture must execute these two steps. First,
Establishing the connection means securing a handshake, often utilizing localized protocols or secure API key exchanges, to allow these isolated agents to safely pass data back and forth. Second, working together means establishing reliable workflows. We're talking about transitioning from simple sequential logic to complex event-driven processes where one agent's output seamlessly triggers another's action.
Which brings us to our final lingering thought for today. Which architecture, MCP or ADK, will ultimately dominate the future of AI integration? We've seen today through the lens of Anasup Consulting that connecting AI agents so they can work together is hands down the most critical hurdle in modern tech. We now know the battle lines are drawn between standardizing context access and standardizing agent toolkits. But you know what? The dust hasn't settled yet. As you go forward, consider the AI tools you interact with or develop. How are they going to integrate into a broader digital ecosystem? Will the seamless workflows of tomorrow rely on the standardized protocols of MCP or the robust toolkits of ADK? The future of connectivity is being written right now. Thank you for joining me on The Explainer. Keep analyzing, keep learning, and I'll catch you next time.